This video is a Potatoes Are Always Awesome production. I hope you enjoy.
In this video, we're going to be going over the citric acid cycle. So, the citric acid cycle is a cycle. It continuously goes, and there's really no stop or ending point. There's only a point where you put in Acetyl CoA, which you got from Pyruvate Processing, where you got the pyruvate from the glycolysis. So, for this to be able to take place, glucose had to be able to be converted to pyruvate in glycolysis. And then the pyruvate had to be converted to Acetyl CoA in Pyruvate Processing. There wasn't a video on Pyruvate Processing because it's a really short and simple mechanism. But essentially, Pyruvate Processing is just taking pyruvate and changing it to Acetyl CoA. You do that by putting in an NAD plus and getting out an NADH. And you put in coenzyme A and get out a CO2 molecule. So when coenzyme A enters, it doesn't produce a CO2. A CO2 is just a product of this, and coenzyme A just enters this. So the net product of pyruvate processing is NADH and the CO2. It changes pyruvate to Acetyl CoA, which can then go into the citric acid cycle and produce more forms of energy that the cell can change into ATP. So the first step of the citric acid cycle is adding Acetyl CoA into the process. So this molecule added onto an oxoacetate and creates a citrate. H2O enters the cycle at this point, and it allows the CoA molecule to come off again in the form HSCoA. So this is the point in the cycle where Acetyl CoA is added on to oxoacetate and changed to citrate. Citrate that can then be changed into different molecules, releasing different forms of energy. Unlike glycolysis, no ATP is needed for this to start, so everything you get out is a product. You're never going to be wasting energy to make a different molecule or to... So the next step is changing citrate into isocitrate, and that is done by the enzyme aconitase. So aconitase allows citrate to be changed into isocitrate. The main difference between these two molecules is that the alcohol here moved down a carbon and the hydrogen moved up one. So that just allows different things to occur later on in the process, as you'll see in the next step. Nothing came out or was put into this step, like most steps. It just allows the molecule to change and be changed into energy later on. Without this step, the energy wouldn't be able to come off the molecule, and it would just be a useless cycle. So the next step is changing isocitrate into alpha ketoglutarate, and that is done by the enzyme isocitrate dehydrogenase. So in this third step, isocitrate dehydrogenase changes isocitrate into alpha ketoglutarate. So as you might be noticing, these two molecules really don't look that similar. The reason for that is that product came off of it during this process. So CO2 was one of the products, as well as NADH, which required NAD plus to be put into this transition. So the CO2 came from this substituent here. The hydrogen came from the alcohol here, resulting in the double bonding alcohol here and the removal of the COO here. The hydrogen from here moved up to fill in the gap here when the double bond with the oxygen was made, which is how you got alpha ketoglutarate. Now alpha ketoglutarate changes into succinyl CoA, which is converted by the enzyme alpha ketoglutarate dehydrogenase. So, as you might notice, the only difference between alpha ketoglutarate and succinyl CoA is that the substituent here was converted into SCOA. That is done by adding NAD plus to get an NADH out of this and putting in HSCOA. Another product of this is CO2, which is a result of the HSCOA adding to the alpha ketoglutarate molecule. So now succinyl CoA is converted into succinate by the enzyme succinyl CoA synthase. So in this step, the SCOA molecule comes back off of the molecule, resulting in this substituent here. Also in this step, ATP or GTP is made depending on what the cell needs. So this is the first step where something comes off of the cycle that can be used directly by the cell. It doesn't have to be converted prior to being used by the cell. So now the succinate molecule needs to be changed into fumarate. The enzyme succinate dehydrogenase allows this to happen. And also in this step, FAD is changed into FADH2. So this step changes succinate to fumarate. The main difference here is that there was a double bond created here. That's where you got the two hydrogens to make FAD into FADH2. FADH2 will now go to the ETC and be changed into ATP, which can be used by the cell. This process was catalyzed by succinate dehydrogenase. Now the fumarate changes into malate, and this is done by the enzyme fumarase. There are no products from this step. H2O just enters the step. So, as you can see, the double bond here was broken, and an alcohol was added here, and a hydrogen was added here. So, that's why you need a water, and that's why you need water to enter the cycle, so you can get one oxygen and two hydrogens added on to fumarate. This product is catalyzed by fumarase. So now, the last step is changing malate into oxaloacetate. This process is catalyzed by malate dehydrogenase. In this step, an NAD plus is converted into an NADH molecule. So this is the final step, quote, of the citric acid cycle. The oxaloacetate that was just made is now combined with another molecule of acetyl CoA to get another citrate molecule, and this process just begins all over again. The total products of the citric acid cycle include one FADH2 molecule, 3 NADH molecules, and 1 ATP-like molecule. Even though this process doesn't produce a lot of ATP, these 3 molecules will go to the ETC and produce much more ATP, about 5, so that can be used by the cell. All in all, this process is important because it creates these molecules which can then be converted to ATP for use by the cell. So this cycle is a complete cycle. There really is no starting and ending, there's only an addition phase. molecules are then broken down or catalyzed into different molecules which take off energy. The only energy is supposedly added in the cell is acetyl CoA. There's no ATP or GTP or anything like that added into the cell, so the products are purely products. You don't have to compensate for anything else that is added into the cell or into the process. The entire cycle looks something like this. I will put a picture of this on Google Docs and put a link to it in the description. I hope this video was helpful, and if it was, leave a like. If you want to know more videos come out, subscribe. And if you have any comments or anything you'd like to see, let me know, and I'll try and get on that or fix it. So I hope this video was helpful, and have a great day.